Alright, welcome back, guys. So this lesson is 4.2, continuing from the previous lesson, which is 4.1, discussing interval notation and inequalities. In this lesson, we're going to look at intersections, unions, and compound inequalities. So intersection unions are not so difficult to understand. However, when you combine inequalities and have a compound inequality and then have intersection and union within that, it can get a little bit complicated. So to introduce the definition of intersection and unions between two sets, we start out by doing this example here. Given the two sets A and B, A is a set of containing 3, 4, 5, 6, 7. B is a set of 6, 7, 8, 9. So these two sets are just finitely many elements or numbers inside them. So we can actually see what are the elements of this set. A is asking us find this set here, A intersect B. So the notation, kind of like an upside down U, this is called intersection. Or sometimes, this is also known as and. Okay, so this notation means what are the elements that are common in A and B, meaning exist in A and B at the same time. Meaning, it usually referred to, so let's say if I say finite, meaning this set here, this set is, all the elements in A and in B at the same time. Okay, well, since these two sets are finitely many numbers within them, it's very easy to look at the two sets and pick out or kind of extract what will be the common elements or common numbers in this case of the two sets, right? So looks like we have a 7 in both sets and then also a 6 as well. So the intersection set is 6, 7. Okay. Now in part B, it's asking for find A union B. So A union B, this set here is referring to the set of all elements or numbers, all the elements in A or in B or in both. Okay, so the looks like a U symbol here, so this is referring to the union. Okay, sometimes we refer this through the word or. Now if we want to look at this in terms of Venn diagram, it's kind of like this here. We have the two set A and B live in this universe U. This is set A, and then this is set B. Okay, so the intersection is this overlap region there. So that's the intersection. Okay, so that's, the one in the red is A intersect B. Okay, as far as union, the Venn diagram looks like this. We have two set A and B again. Okay, A and B. So the union is the sets that contain elements in A and then elements in B or elements in both A and B. But we're not gonna double count. If we count the elements in A or all the elements in A already, we're not gonna count the elements that in the overlap region to B, because those elements also belong to A and B at the same time. Okay, so red, right? So this is A union B. Okay, so notice that this is the thing you look at for. You count the elements in A, you count elements in B, or in both, but you don't want to double count. Okay, so in this problem here, the sets A union B is the set of all elements in A. So first we'll list all the numbers in A. Okay, and then we list all the numbers in B, which is 6, 7, 8, 9. But you see how we double count the 6 and 7, because 6 and 7 is already in A, so we want to omit that. Okay. So it's just gonna be 3, 4, 5, 6, 7, 8, 9 as the set the elements in the set A, union B. Now, with a small set like this here, it's pretty straightforward to look at the two sets and figure out their union and intersection. It's not so easy when these sets are arbitrary sets or sets that contain infinitely many of these numbers or just so many elements in it. We can't really list out all of them. We can only rely on our intuitions or the way we graph those solutions or understand what it looked like, insight, and then from there we kind of rely on the definition of intersection and union and kind of see what would be the potential or is the union or the intersection between two sets that involve infinitely many numbers. Okay, and that's what the next exercise is going to show us. Okay, so for the next example, okay, we have two sets. We have this set here, and then we have this set here. So these two sets are written in the inequality form. So the first thing what we want to do is we want to simplify these two sets first, and then we're gonna find the intersection of the two sets, and that's what this is saying here. Okay, so for the first set, okay, I'm gonna go ahead and simplify that. Okay, I'm going to take 7x plus 2 greater than or equal to 9, and then that become 7x greater than or equal to 1. So this is my set A. My set A is all the numbers greater than or equal to 1. Okay, so in other words, this set here, A, is the set that contains 1 as the lowest number, and then it goes all the way up to positive infinity. Okay. What that look like in terms of the number line, here's 1, and here is all the numbers greater than 1. Okay, so you can, as you can see, this set A, there's no way we can list out all those infinitely many numbers greater than 1. So we can only capture it through a graph or interval notation here. So that's my set A. Okay, so now moving on to set B, I'm going to go ahead and simplify this here. Set B is 4x less than or equal to 7, so 4x less than or equal to 4, and then divide by 4, so that means x is less than or equal to 1, so let our set B be all the numbers less than or equal to 1, and that means B is equal to negative infinity up to 1, okay, and what that look like in terms of the graph, it looks like this here. Here's 0, here's 1. So all the number less than 1 or equal to 1 is to the left of that, right? Okay, so again, this set contains infinitely many numbers as well. We can't list out all those numbers. We can only capture that using interval notation or through graphing. So now the question asked, here's the question, okay? Solve this, meaning find the set of intersection. So it's saying solve A and B, or A intersect B, okay, and here's our set A, here's our set B there, okay. So this is asking, okay, if I take A as the setup from 1 to infinity, intersect that to set B, which is negative infinity to 1, what would be the elements, what will be the numbers that appear in set A and at the same time in set B? And if you look at these two sets here, the only number I can think of is 1. So this intersection set here is just 1. Okay. Another way to see that is when you graph these two graphs. So you have 0, 0, here's 1. Okay. And when you draw these two graphs on top of each other, and you want to see what will be the intersection be, well, look at the two graphs. The only overlap elements is 1. So from there, we can say that A intersect B is just going to be 1. Okay. Right. Moving on to the next example, we're going to solve a compound inequality using an OR statement. Okay. So this is asking for solve A, excuse me, A, why can't I do that? A union or B, okay? So step one, let's go ahead and simplify our first set. Okay, so that's negative 2x less than or equal to 3. Divide by a negative, switch our inequality. Okay. So just divide by negative, switches inequality sign. Okay. All right. So set B is, set A is all the numbers greater than or equal to negative 3/2. Okay. And that means A is bracket negative 3/2 to positive infinity. And the graph looks like this. The graph looks like is 0, is negative 3/2, and it's going to go from negative 3/2 all the way up to positive infinity. Okay. Our set B is negative 1/2 x plus 1 greater than negative 2. We're going to solve for x, subtract 1 both sides, so we're going to get negative 1/2 greater than negative 3. And then now we're going to times both sides by a reciprocal of this, which is 2 over 1, negative 2 over 1, negative 2 over 1. And when we times or divide by negative signs, inequality, the inequalities switch again. So we're going to get x here, and then instead of greater than, it's going to switch to less than. Okay. And then over here we have a positive 6. Okay. So that is our set B. B is all the number less than 6. And that means as interval notation, it's going to go from negative infinity to 6. And we don't want bracket around negative infinity. Okay. All right. So that means here is 0, here is 6. Everything to the left of 6 is less than 6. All right. So now we want to solve the OR statement. Okay. So part B is saying that solve A or B, meaning solve A union B, or it's asking to solve x less than 6 or no, that's B. So I want to write A first. So this asking us to solve x greater than equal to negative 3/2, or x is less than 6. Okay, we're supposed to solve that. Okay. So the set of union means we want to combine all these numbers in both sets. We want to combine all the numbers that are greater than or equal to negative 3/2, and then when we want to combine all the numbers that are less than 6. Okay. So to have a visual of these two sets, we draw both of them on top of each other to kind of see that. Okay, so here's 0. Here's 0. Okay, so for set A, all the numbers greater than or equal to negative 3/2. So here's negative 3/2. All that numbers greater than or equal to negative 3/2 is this direction. Okay, now the numbers that are less than 6 is this direction. Okay, all right. Remember, this is the OR statement. Okay, meaning compound inequality OR statement. OR statement mean, it's either in all the elements in A or in B or in both. So mean we combine both sets together, not taking the intersection. Okay. So now, if we take A was, if we take negative 3/2 infinity union negative infinity to 6. That will give us, okay, well, let's see what's going to give us here. Well, for the OR statement, we consider everything in A, okay, and then we consider everything in B, but then everything in B already had things in A, okay, so which is this part here. So this part here is already in A, okay, so that's already in A. So we're just missing this part here as well to combine that. So in this case here, the set that contain everything in A and everything in B and everything in A and B is actually everything on the number line, right? So A is up to this part, and then B include this part as well. Okay, so in this case, the set of union is gonna be from negative infinity to positive infinity. It's gonna be the entire number line that represent the OR statement for both of this. Okay.